Hello again, Psych 370 students, and welcome to the first of several video lectures that I'll be providing for you during this third week of the course. As you can see in the syllabus, your reading assignment for this week is Chapter 2 of the textbook. That chapter discusses the study of learning, and it begins with an overview of the so-called natural science approach to the study of learning, which involves making 4 basic assumptions. So that's what I'll be talking about in this video lecture. I just want to say a little bit about each one of those assumptions. First of all, the first basic assumption that natural scientists make is that all natural phenomena have causes. And learning and behavior are naturally occurring phenomena, so we assume that they have causes. In other words, when behavior changes, it changes for a reason. Something caused that behavior to change. It could be an experience that the person or animal had. Like I talked about in last week's video lecture, learning involves changes in behavior that are caused by experience, but behavior can change for other reasons too, like fatigue or injury or maturation and so on. But either way, the natural science approach to the study of learning involves making the assumption that when a behavior changes, it doesn't just do so randomly. Those changes don't just happen due to chance. They're caused by something. Now, guys, this idea that every natural event has a cause, it's a very basic tenet of science, and it's sometimes referred to as determinism, as in one event's occurrence is determined by, it's caused by the occurrence of another event. So that's called determinism. And speaking of determinism, another related assumption that natural scientists make is that these causes, these determinants that we're talking about, they are natural events. So natural phenomena are caused by other natural phenomena. So guys, if we want to explain behavior scientifically, then we can't say that what caused a behavior was something like psychic energy, right? Or spiritual forces, or magic, or fate, or anything like that. Instead, we assume that behaviors are caused by natural phenomena. They're caused by something in the physical universe, like, say, a particular stimulus or a particular experience. So behaviors have causes. Those causes are natural events. And the third assumption here is a fairly obvious one, which says that the cause of an event has to take place before the event itself. And the fancy way to say that is that the cause has to take temporal precedence over the effect. And so obviously we assume that causes occur before their effects. We assume that causes precede effects. Causes take temporal precedence over effects. So for example, if I get a headache and then I take some aspirin, well then clearly it can't be that the aspirin caused my headache, right? Because I already had the headache when I took the aspirin. But if my headache then goes away after I take the aspirin, well, then it's at least possible that the aspirin caused that. It's possible that the aspirin caused the disappearance of my headache. Now, it may not have. There could still be some other explanation for why my headache went away. But the fact that the aspirin occurred first, the fact that the aspirin took temporal precedence over the relief, that means that it's at least possible that the aspirin caused the relief. And so when we do experiments in science where we're trying to show that a change in one variable caused a change in some other variable, we take this assumption into account by manipulating the independent variable first and then measuring the dependent variable later. In other words, we make sure that the manipulation of the independent variable takes temporal precedence over our measurement of the dependent variable. And then finally, guys, the fourth assumption of natural science is that the best explanation for something is likely to be the simplest one. It's likely to be the most straightforward one. And this is known as the law of parsimony. Now, guys, parsimony, that term, is defined as the quality of being frugal, thrifty, or economical, okay? So let's say that we have two possible explanations for the same data, the same observations. And let's also say that both of these explanations have the same explanatory power. In other words, they're both equal in terms of how well they explain the existing evidence and how well they predict future observations. Well, if that's the case, then natural scientists are going to prefer whichever one of those theories is simpler. They're going to prefer whichever one involves fewer concepts and fewer variables. So for example, let's consider the interesting observation here that shortly after a kitten is first born, its mother will lick it until it's clean of all the fluid that covers it. So mother cats will do that with their kittens. So how can we explain that behavior? Well, we could explain it by saying that the mother does this because she somehow knows that she has to clean her kittens like that, because if she doesn't, then the kittens will get cold and they'll freeze to death. So that's one explanation that we could propose for that observation. But we could also explain the mother's behavior by saying that she does this. She licks the fluid off of the kittens like this because that fluid tastes good to her. And all else equal, that is the explanation that a natural scientist is going to prefer because it's simpler. It doesn't require assuming the sophisticated mental process on the part of the mother cat. So it's more parsimonious, in other words. Now, here's another example involving a horse named Clever Hans that you might have heard of before. It's a pretty interesting story, though. So in the early 1900s, there was this German math teacher, Wilhelm von Osten was his name, and he was convinced that animals actually have far more cognitive ability than we humans usually give them credit for. And in particular, he thought that his horse, a stallion named Hans, could count. And von Osten actually taught Hans to count, he claimed, by presenting Hans with groups of objects and then having Hans tap his hoof the appropriate number of times. So for example, if he was shown 3 apples, then Hans would tap his hoof 3 times. If there were 4 apples, he'd tap 4 times, and so on. Eventually, Hans got to where he didn't even need to see the objects. Von Osten could just say a number like 5 or write the number 5 on a chalkboard, and Hans would tap his hoof 5 times. And not only did Hans go on to learn how to add, subtract, multiply, and divide, but he also learned the alphabet. So 1 tap for A, 2 taps for B, and so on. He could spell out the names of objects, and he could even identify musical notes like F sharp or B flat. So Hans and Van Osten took their show on the road. They did these exhibitions all over Germany showing off this horse, and Clever Hans became quite a sensation. The problem was no one really knew how Hans was doing all of this. And even though some people were ready to acknowledge that this was just an intellectually gifted horse, others weren't so sure. And one of those skeptics was a psychologist named Oscar Pfungst, who, with von Osten's permission, ran a number of tests on Hans in 1907. And guys, what Pfungst found was that, for one thing, if the person testing Hans didn't know what the answer was, so for example, if they were handed a card with a number on it and they didn't look at the number before showing it to Hans, well, then Hans usually got those trials wrong. He usually made a different number of taps than what the card said. And if Hans couldn't see the questioner, if that person's face was hidden from Hans, then Hans usually missed those trials too. Now, when Hans could see the questioner, and when the questioner did know the right answer, then Hans's accuracy was around 90%. In fact, it was reported that he had the mathematical abilities of a 14-year-old human. But as that psychologist, Pfungst, discovered, what Hans was really doing was watching the person who asked him the question, and then he'd just tap until that person's facial expression changed. So even people who weren't trying to give Hans any signals would often involuntarily sort of jerk their head upward and change their expression as soon as Hans got to whatever the correct number of taps was, because they were anticipating that that would be the last tap. And that's what Clever Hans was actually responding to. And so as scientists, we prefer that explanation. We prefer the explanation that's based on the posture and the facial expression of the questioner, because it's simpler. It requires fewer assumptions about the cognitive abilities of the horse. It doesn't require a radical revision of our previous understanding of things. And so it's more parsimonious. Now, you might also hear the law of parsimony being referred to as Occam's razor, after a 14th century philosopher named William of Ockham. And guys, while I'm talking about this stuff, I do want to show you a really quick video about it. So here that is.
Sheldon, why is this letter in the trash? Well, there's always the possibility that a trash can spontaneously formed around the letter, but Occam's razor would suggest that someone threw it out.
Okay, yeah, so why is this letter in the trash? Well, like you said, I guess it's possible that the trash can just spontaneously formed around it, but it'd be pretty difficult to explain how and why that would have happened. I mean, that would require assuming that something just happened that has never happened before. And so it's more parsimonious to conclude that it's in the trash because somebody threw it out. So the law of parsimony, or Occam's razor, has to do with how we should sort of cut out the fat when it comes to our explanations of things. We should refine our theories so that they don't include any extraordinary, unnecessary, unwarranted claims. And so in that regard, scientific theories are kind of like machines. Because if you're an engineer, then the best way for you to design a machine is with the fewest components possible, right? Because that way there are fewer things that can break and make the machine stop working. Well, it's the same way with theories. The less complicated they are, the fewer assumptions they make, well, then the fewer ways there are for them to be wrong. And so when it comes to explaining why a behavior occurred, we always want to start with the simplest explanation we can. And then only if that explanation proves to be inadequate will we move on to a more complex one. Okay, so natural phenomena have causes. They're caused by something. They're determined by something. That's called determinism. Those causes of natural phenomena are natural phenomena themselves. So they're not supernatural. They're not mystical events. They're naturally occurring biological or environmental events. Causes occur before their effects. Causes take temporal precedence over their effects. And all else equal, we're going to prefer a simpler explanation over a more complicated one. And again, that is called parsimony or Occam's razor. Okay, well, that's going to do it for this video lecture. But as always, if you have any questions about anything from this video or any of the other videos that I've made available this week, then please let me know. Take care.